Well, hello everyone. We're now moving on to number three, which is essentially um, transformations functions, but in this case, transformation of exponential functions. And we're going to basically do the same thing that you would have done when we did transformations of quadratic functions, transformations of um, polynomials like x cubed, whatever the function might be. The usual types of transformation are move it left, right, move it up, move it down, reflecting the x, reflecting the y, vertical stretch and vertical shrink. And do not be surprised if exactly the same thing's going to happen here. So if we have, if we wanted to do a transformation, the first thing you need to do is identify the basic building block. So let me, because we're not going to do very accurate sketches, there are really only two basic shapes. If you get a function that has a base, let's say less than 1, and then what you do when you get a base, like here, the base is 4, bigger than 1, and then half to the power of x, for instance, we know that it would go like that. And that point there would be 1. And if you go for bases bigger than 1, that was your shape. So what you're going to do to start with, if you wanted to do a very basic, what does it look like? Not something you could read off any answers accurately from, but you want to know using transformations what its shape would look like. You start off by which one of these two is it? Is it this guy or is it that guy? And then you can move on to the types of things that transformations might do. So for instance, let's do as our kind of basic shape 2 to the power of x. And let's do some transformations on 2 to the power of x and see if we can figure out what the shapes would look like. So to start with, this guy that I'm drawing right now is what 2 to the power of x looks like. Now suppose I had a transformation and it was this one. Pause for a minute. You want to figure out what that transformation actually does. Okay? What do you get when you take a 2 to the power of x and you just add 7 to it? And I hope what you would say is, oh, when you add 7 in this form, then that means you move the shape, right? You move it up 7. So if you start with 2 to the x and you subtract 3, then that would move it down 3. Now, the brackets are there for emphasis. You probably wouldn't see them. They probably just normally you would write it like that. Now, what transformation is happening here? What do you think? Hopefully you've said to the right 3. And hopefully you would then say to the left 7. Now only 2 more transformations. There's one of them. And there's the other one. Now, hopefully you would say, these are reflections in the X and Y axis, which they are. But will you be able to figure out which one is a reflection in the X and which one of these is a reflection in the Y? Because you don't want to get them back to front, do we? Okay. We have 2 to the negative x, and we have negative 2 to the x. I call this the negative on the outside. I call this situation the negative on the inside. And this one here, the bottom one, that's a reflection in the x-axis. And this one is a reflection in the y-axis. So here are the 6 typical transformations we're going to deal with. Move me up 7, move me down 3. Move me to the right 3, move me to the left 3. Reflect me in the y-axis, reflect me in the x-axis. And of course, you can then do combinations of them. Suppose I wanted to figure out what that would be. Let's show you how you do it. You'd start off with your basic building block, which is 2 to the x. And we know that 2 to the x kind of looks like this. Now, the next thing that's going to happen to it is that negative. So we're now going to do, what would negative 2 to the power of x look like? It would be a reflection of this guy in the x-axis. So make this one a dotted line, and it would go like this. And this guy would be negative 1. So that's what that guy looks like. Now, so you've moved it by, or you've transformed it by reflecting it in the x-axis. Now, what does this thing do? Right? Well, it moves everybody down 1. And that's where it gets a little bit tricky. The only point I really know its coordinates for is this one. So if I move it down 1, I've got that. Now, I've got to imagine taking this entire shape and moving it down. But there's something else hidden in here that we haven't really talked about. And it's on the left-hand side where my pen is. This is a horizontal asymptote going along the x-axis. When you move this shape down, in this case 1, that horizontal asymptote also moves down 1. And that horizontal asymptote is now no longer the x-axis, which is y equals 0. It's now moved down to there. So you've got your boundary, your horizontal asymptote, you've got your point, and you know it's this shape, drop down 1. So you do your best to draw like a road. And now we have the final result. Try another one. Let's suppose I wanted to do 2 to the x minus 3 plus 1. I'm going to sketch that guy. So let's start off with my basic building block shape, which is 2 to the power of x. And we know what 2 to the power of x looks like. It looks like that. Now, what are the transformations this time? Well, you're going to move me to the right 3, and then you're going to move me up 1. So let's just move it to the right 3. And you take this point and you move it to the right 3. It's now there. Now, all the other points slide to the right. But if you just move something to the right, the horizontal asymptote is still where it always was. So what you basically do is you try and draw a road. So, not very nice looking road, but you try and do the shape. Kind of move to the right, not that well drawn, but yeah, I did the best I could. So that's what 2 to the power of x minus 3 looks like. Now keep that point in mind and try and do the choke. That's not a very good version of it. Try and do the choking slide shape. Now I'm going to move it up one. So if you move it up one, it's now, say, here. The horizontal asymptote also gets moved up one. So it's now going to be not the x-axis anymore, but one above it. And this is getting pretty messy. So, oh, I don't know if I've got any other colours. No, really. I'll do it thicker then. So I have to pass through this point and level off here and climb up there. So it's going to be and there is your g of x. I'm going to return to the first one now, which is this guy. And let's look at some of its basic properties. Well, the domain of f of x, right, which is what, this red guy, the domain is still real numbers. Let's do the range of this function. Well, if you look at the red function, which is the guy f of x is equal to, do you see that it only gets to there? So the biggest number it ever gets to for a y value is -1, but it curves down the way. So it can be any number way down at minus infinity. It gets up to -1 and then stops. So that would be the range of y values. So let's return to this guy, to me. Still all real numbers. And that's not the right one. Bear with me. I'll get it in a minute. Only so many. Oh, there it is. Throw those pieces of paper away. Remember, g of x is this very thick guy. Now, its domain is all real numbers. Now let's see what the range in the y values looks like. Well, they get to 1 and anything above it. And that would be that fella. You can do more than just 2 transformations. It is possible to do 3 or 4. I'm not going to draw this one, but I will create one. Maybe that plus. You would start with 4 to the x. Move it left 2. That is, now you reflect it in the x-axis. And last, you do the add 3, which means you move it up 3. And since it's 4 to the x, your basic start shape would be that. You could, however, have this fella. Now your starting shape is that guy. Actually, let's put an extra negative in there, right? That's your starting guy. And that guy looks like that. Now you've got this fella to take care of, this one to take care of. Well, I think I would take care of this one, which is a reflection the y-axis. Then I would take care of this one, which is the reflection in the x-axis. And then I take the last transformation, which would be essentially move it up too. So can you imagine taking this shape, reflecting in the y-axis, reflecting it in the x-axis, and then moving this shape up too. And that is the end of transformations of an exponential function.